Hello, everybody. Welcome to lecture one, describing a data set. So this is our first of 9 lectures, and what we will be talking about today is just when you open up a data set, what are you looking at? How do you describe this data? So we're going to take it baby step by baby step in order to get to where we need to be, where we are statisticians and we can tell you everything about a data set. But for today, the first step is just opening it up and being able to say, I know what that is, I know what that is, right? And so that's what we're gonna do. So let's describe a data set. Let's click. All right, so how do we describe a data? Oh, excuse me. So an introduction to statistics. This is a really great video. I thought it was interesting and a good way to sort of let people know why statistics matters. Why is it important? It's a very short video, so it's not going to take all day. And it also shows you that everyone uses statistics. And so it's a very, it could pay off if you understand how to talk in stats lingo, but also more importantly, how to share information in a way that is in layman's terms for people who don't know stats at all, right? So having this understanding of statistics could definitely pay off for you in the long run, both personal, right, as well as professional. All right, so the first thing we need to know about data is that data helps us, is that we can use frequency distributions, frequency tables to simplify data. Data can be very overwhelming, and it's very important to understand what that overwhelming information is, but we use, I need to take my timer off because it just moved and I don't know why. I'm gonna not use the timers. All right, so it allows us to simplify data. So you open up a data set, you open up a spreadsheet or what have you, and it gives you all kinds of variables, numbers, words, everything, right? And a frequency distribution allows us to take all those words, all those numbers, and put it in this format right here, and thereby simplifying our lives, right? It demonstrates patterns easily. It summarizes data very clearly, right? We, without having taken this course, would be able to look at this chart and know exactly what it's trying to tell us, right? We can see that the years are at the bottom, and that it's some information about the rate of divorce to marriage over the past 54 years or so. Okay, so we can see that it was kind of at about 23%, and then it skyrocketed in the, let's see, that's the late 60s, 70s, continued to go up, and then it now has sort of leveled off again and has stayed at this high rate of roughly 50%. And it's staying there. Hopefully it'll plummet at some point, but right now it's where it is. So this is what statistics allows us to do: take data and make complete sense of it. Okay? So as we get started, we have to be speaking the same language. And so here are some definitions that we are going to be using for the next 9 lectures, right? And so it's important for us to understand what these words mean, because they are life for us as we do statistics. So the first is a case or an observation. That's the object described by the set of data, the data set. Okay, so the data set might be talking about a person, right? And maybe 500 people completed that survey. So 500 observations or 500 cases, right? It could be talking about a group, and maybe 500 groups were surveyed. So that's each group is an observation, right? It could be talking about an object. It could be talking about an event. This event happened here, happened in LA, happened in Atlanta, happened in Baltimore, happened in Philly, New York, right? So understanding what the word observation means is important, because one observation is one entire case, one person, one group, one whatever, okay? The variable is the question that is being asked. So the question that's being asked, so for example, you do have your survey before you. Someone asks you, how old are you? And they ask you, what's your race? What about your gender? And what language or languages do you speak? Right, so these are all questions. We know them to be questions. In statistics, we also know them and call them variables, okay? And then our third definition here is value. So the value is the answer to that question, your response. So someone asked you your age, right? And this person said, I'm 47. Someone asked you your race, they said, hey, I'm Hispanic. They checked off Hispanic, right? They asked their gender, I'm female. They asked their language, well, I speak Igbo, I speak English, I speak Ebonics, I speak a little bit of Spanish, working on Dutch right now, right? So those are the responses to that question. So values are your responses. So again, our case, that's you. The variable is just the question, right? And your value is the response to that question. And a full observation of you could be that is that you answered all 18 questions on that sheet of paper, on that SurveyMonkey survey, right? You answered all 18 questions. That is one observation. Another person answered all 18 questions. That's another observation. Another person answered 15 of those 18. That's still another observation, right? Regardless of how many questions they decided they don't want to answer, I'm skipping it, there's still an observation. They are still a case. They are still a person, okay, that was part of this set of data. So we've got through slide 1 so far, the first set of definitions. So let's go to our second set of definitions. So now that we know what an observation is, me, you, right? We know what a variable is, the question being asked. We also know that a value is the answer to those questions. Okay, and so now we want to understand the types of variables, because variables are the everything of a study, right? You're not going to have a study and have no questions being asked, right? You're going to ask questions in a study. And so we want to understand the different types of questions that were being asked. So here are the 4 different types, or I would say 3 different types of questions. And the 4th one you see here is a different color because it can be any of the other 3. So we're going to talk through that, okay? So interval variable, also known as a numerical variable, that is a variable where its responses, its values, as you can read for yourself, its values are exact numbers. So a variable, we don't know what it is until we know, or what type of variable it is, until only when we know the types of values that are out there for that variable can we know how to classify that variable. So if I asked you your age and you told me 47, I know that's an exact number, right? Based on what this says right here, that's an exact number. So I know that this variable is an interval variable, a numeric variable. Say, for example, I asked, what's your age? And I only gave you categories. I wouldn't say only, I gave you categories, right? And so you checked off 40 to 50 years old. What does that mean? Is that an exact number? Well, as I'm reading it, it says 40 to 50. That means I don't know your actual age. I don't know your exact age. So we can't look at the variable age and say, oh yeah, that's interval, because in this case, in that second case, it's a category, right? It's a category. So if we know that if you see a variable and it has values that say 0 to 10, 11 to 20, 21 to 30, and so on, and someone selects 40 to 50, 41 to 50, then I know that's not an exact number. So I now go to bullet point number 2. It's a categorical variable. Okay, so because it's a categorical variable, now I have to make a decision. Does it have some order about it, or is there no order? Okay, so a categorical variable, let's ask the same question. What's your age? Are you here, 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 or here? Pick one of these 4 categories. Well, regardless of the category you pick, I know that these are categories. So now I'm trying to decide, is there order or not? Well, is 50 the category 40 to 50? Is it more? Can we decide whether it's more or less than the category of 30 to 40? Probably yes. That's not even probably, absolutely yes. We know that 40 to 50 is a higher set of numbers, categories, than the category 30 to 40, period, right? We know that the category 0 to 10 is much lower than the category 90 to 100. So we know that we can never say, well, 30 to 40 is first, then 0 to 10 is second, then let's go with 50 to 60 next, and then let's go with 11 to 20. No, there's absolutely no order about that, because we know that there is a right order, a right way to organize those values, to put them in order. That because of that, we can now say this is an ordinal variable. It's an ordinal variable. So we already scratched off that it was a numeric or interval variable because the variable had no number, no exact number, right? So now we knew it was a categorical variable. And so if it's a categorical variable, does it have order or not? Well, let's look at another categorical variable and decide whether it has order or not. Okay, so what is your race? Well, she's given me the option of white and black and Hispanic and Asian and Native American. So is there order to it? Well, besides alphabetical order, in terms of statistics, we're talking numerical order, right? We're talking numbers. We're talking there's one that's greater than the other. With that variable, with that question that we just asked, what is your race? There's no order. I mean, in the real world, hopefully, there is no order, right? There's no saying, okay, black is first, and then, you know, white is second, and then maybe, right? There's no order. There's no order about another variable, let's say religion, right? There's categories. There's Muslim, there's Christian, there's Buddhist, there's, you know, other religions, there's atheists, there's agnosticism, right? So there's lots of other categories, but can we now start placing things in order? Not unless you want a good argument out of that. So there are certain questions that the values for them have no order, and we have no business putting order to them, and because they're way too controversial, and there's really no right order about it. So for those, we now call ordinal variables, right? So we went from interval, which had exact numbers. I am 47 years old. Then there was a categorical variable that the values were, you had to choose a category, and she chose 47. So she chose 41 to 50. So she chose a category. We don't know her exact age anymore. We only know she's in this category. And then we've got another variable, gender or race or income, or race or religion, that has no order at all. And that's what this third bullet here, nominal variable. It's still categorical, but now it's a nominal variable, okay? And the nominal variable, no natural order. And these are some examples here. Now, gender, yes, we know females are better than males, but just to avoid the controversy, we're going to say, sure, it's a nominal variable. We're going to just say, sure. That's a joke. Okay, so, and then the fourth category is dichotomous or dummy variable. So with the dummy variable, the simplest, but besides interval and between interval and dummy, these are the two easiest ones to figure out. Interval, is it an exact number? If it is, boom, we know what to do. Dummy variable, does this question have only two options of answers? Okay, a prime example is, well, in the traditional sense, is gender, right? It's only male or female. Today, you know, it could be a whole lot of other categories possibly, right? But we know traditionally that the values that it can exist are male or female. And so that is a variable that, even though it's a nominal variable, it can also be a dummy variable, because dummy variable, the only criteria is that there's only two responses. There's only two responses, male, female. Did you get promoted? Yes, I didn't. Yes, I did. No, I didn't. Or check box, promoted, not promoted, right? So two responses, that's it. There are variables that can be ordinal, like that have order, categorical order to them, like a Likert scale, strongly agree, strongly disagree, neutral, and so on. A variable like that, we could even make that if we decided, let's not look at the neutral. Let's only look at people who agree and disagree. So we're going to put the agree and strongly agree together, and we're going to put the disagree and strongly disagree together. And so we're going to only look at those two categories. Is there order? Yeah. We could, there is order about it. Agree might be, agree and disagree, and then strongly agree and strongly disagree. Before, there was definitely order about it, because it's a Likert scale, there's order, right? And then now that we've broken it down or combined it to be only two categories, it's not only just an ordinal variable, but now it's a dummy variable, because the only criteria for dummy variable is that it has two responses, two values. Okay, so an interval variable can also be a dummy variable, right? The variable could be, I'm looking at a survey of a study of only newborns, so 0-year-olds and 2-year-olds. That's it. 0-year-olds and 2-year-olds. Okay, so so we know their exact age, 0 and 2, and we also know that those are the only two values in that particular variable. So not only is it an interval variable, it's also a dichotomous variable. Just like that. We've gotten through two important definition slides, and we will move on. All right. So let's practice. A researcher wants to understand people's attitudes toward premarital sex. She creates a survey and asks this question to 500 people of various races, ages, educational attainment, and religious beliefs. All right, so how many observations are in this data set? Hopefully your answer is 500, because 500 people were questioned. Okay, what are the variables, or said a different way, what are the questions that were asked in this survey? Well, let's see. Give you a second there. Okay, hopefully you're saying age, race, educational attainment was asked, religious belief was asked, but hopefully you said a fifth one, which is the main question that the researcher wanted to understand, is what's your opinion about premarital sex? So 5 variables, 5 variables. All right, what are the possible values in this data set? So a But what's a value again? A value is the answer to the question. What's one's response? So a possible response maybe to premarital sex is, sure, I'm for it. Or no, it's wrong, right? A possible response for age could be 47. A possible response for age could be 41 to 50, right? Depending on the type of variable that age is, depending on however the question was written on the survey, right? Race, a value, possible value could be I'm Black, right? Educational attainment, let's say 16 years of education. What would that be? Probably a college degree. Or we could checkbox college degree, right? Or religious beliefs. Someone could say I'm Muslim, I'm Hindu, I'm Sikh, I'm whatever, right? All these different religions. So what is one possible observation in this data set? One possible observation, let's see. So what is an observation again? Hopefully we're saying it's one person. It's one of all the people that were in the survey. It's one person, right? So one person could have, so I look at one sheet of paper that one person responded to, and that one possible observation is, for this example, premarital sex is wrong. I am 47. I am Black. I have a bachelor's degree, and I am agnostic. So one possible observation means that you've said all 5 of their responses for all 5 of the variables for that one person. Okay, good. So what is the sample size, though, for this study? Hopefully, we're saying 500 because question 1 and question 5 are the same. How many observations are there? Possibly 500 if 500 people responded. What is the sample size? Hopefully 500 because hopefully 500 people responded. Just like that. So now you know that observations or cases or sample size all mean the same thing. We also know that variables mean the same thing as questions. Values mean the same thing as responses or answers to those questions. And we move on. Okay, so now that we have definitions down and we've practiced those definitions, let's look at a third set, okay? And this is a frequency table. It's a lot going on here, but I promise you by the end of slide 7, this will all totally make sense to you. This is a frequency table. This is our first of many ways that we will describe data. And so we're hopping right into stats now because we understand the basic 2 sets of definitions that we looked at in previous slides. And so our third set gets us now into stats. Stats that you've probably done in your lifetime, possibly not too, but it's still a baby step. So we're not diving in too deep just yet. So what you see here is a frequency table. At the top, you should see the variable name that was recoded in Excel as, or in this case, it's SPSS data software. It says premarital sex or sex before marriage, okay? And the variable is called sex before marriage, or what is your opinion about premarital sex, okay? Some of the values we can see here after the word valid, we have 1, 2, 3, 4. That means the researcher coded these variables, and we'll learn what coding means soon, but coded these variables, these values as 1, 2, 3, and 4. So 1 was coded as always wrong. 2 was almost always wrong was coded as 2. Everyone who checked boxed sometimes wrong was coded as 3. Everyone who checked off not wrong at all, they were coded as 4. Okay, so how many people said not wrong at all? If we go over to that column for frequency, we see that 280 people said, nope, not wrong at all. How many people said wrong always? 156 people. So we go over from that always wrong and into the frequency column, and we can see the frequency, the number of people that said it. 156 people said always wrong, right? So you see the total is just adding up all 4 of those values. Other values that don't matter toward this question are people who said, I don't know. People who didn't even respond, just decide not to say I don't know, check the I don't know, they just didn't respond. It's none of your business, right? Or people, or something happened in the transfer of the data, something happened. 340 observations are missing. Something went wrong in the system, there's a system error, and somehow of the 1,000 people that we tried to survey, now 340 of them, their data is gone. Oh no, that's a nightmare, but that's not your portion. That will happen to you if ever you have to do this. But this is to illustrate that we had valid responses to the question, what's your opinion about premarital sex? So those 4 points there help us understand one's opinion. The other missing values, we call them missing values because they don't contribute at all to our understanding of that question. They're not contributing at all to us understanding people's opinions about premarital sex because there's error. So we don't know their opinion. There's people who decided not to answer. And then there's people who said, you know what, I honestly don't know. So even that doesn't help. So, because the question I think that this researcher wants to understand is the level of right or wrong that it is. So the don't knows just got spit out. They got spit out. Okay. So column 1 and column 2, wow, we're good to go, just like that. We know column 1 is telling us the values that are important, the values that are not important, so they're missing, we call them missing. The total of the values that are important and the values that are not gives us 1,000, right? And then the second column tells us the actual numbers of people who said each of these values or something went wrong in their value, right? So we can see that. We call that absolute frequencies. Absolute frequencies are the number of observations for a particular value, the number of observations for a particular value. That makes sense because we've already talked about it. 156 people said always wrong. 56 people said almost always wrong. Sometimes it might not be right. And so now let's move over to the next column where we actually have percentages. So the first column, notice there's a percentage column and there's a valid percentage column. The first one deals with the entire sample, including the people that had missing data. So we included all 1,000 of the people in the survey, even though we shouldn't, because some of this data, much of this data is not useful, right? So relative percentage, relative frequency are percentages. Absolute frequencies are the exact numbers, the counts. Count 1, count 2, count 3, 500 people, 1,000 people, right? Just basic count. Relative frequency is relative to another number. So what number is it relative to? Well, that's the difference between the regular total percentage and the valid percent. The percent, we're here written as percent, which I would also say total percent, is the total number of observations. In this case, we had 1,000 people that we handed that question to. What's your opinion about premarital sex? So we handed that question to 1,000 people, right? How many valid responses did we get? 636. But how many people answered? Were given that question? 1,000. So the number that this relative frequency is related to is the total number of people that we said, answer this question, please. Oh, what in the world was that? Okay, so, oh my goodness, it's like attacking me. Okay, so, oh, sorry. So, Now, the valid percent is the percent based on the valid number. You probably guessed that already. So the valid number is 636 people, right, that had actual valid responses to our question about premarital sex opinion. So in the first column, it's based on the 1,000 number. In the second column, the percent is based on the 636 number. So with the 1,000 number, let's do a total percent. So 156 people out of the total of 1,000 would give us 15.6%. Okay, so 156 divided by 1,000, of course, multiply by 100 to get percent, and we would get 15.6. Okay, the second number, 56, divided by 1,000, we should get 5.6%. And so on. We can do that all the way down, dividing by the number that we're relating it to, 1,000. Okay, the next number, the next column we should look at is the valid percent. Just thinking about my waving off. Okay, it's a valid percent. With the valid percent, hopefully you guessed it, but the number we're relating it to is the total for the valid responses. That total, 636. Okay, so for the 24.5%, how did we get that number? 156 divided by the valid total percent, 636 times 100, that gives us 24.5. Now let's stop there, because this is really important for us to understand that depending on which percentage you calculate, you can get very different answers, right? People that said it's always wrong, if we use the valid percent, we diluted that number. So maybe it's possible that someone might have had an agenda they wanted to portray, and they wanted it to be so that, you know, we don't publicize it. People think it's always wrong, right? So, only 15% said it's always wrong, you know, or only 14% said it's sometimes wrong. But in actuality, it's 24.5, almost 25%, almost a quarter of the people said that for both, right? For always wrong and sometimes wrong. That's a large number. For not wrong at all, that's 44%, right? Before we said 28, it's just 28. That's not a big deal. Now it's almost a majority number. But one, if you could do this unknowingly. You could do this knowingly with an agenda to maybe say, we don't need to create this policy, or we don't need to be concerned about this issue because, see, only 15.6% thought this, when in actuality 24.5% thought this, right? So we have to understand the way the data is summarized in order to understand whether we're using the right measures, because knowingly and unknowingly, especially unknowingly, we could manipulate data and we could share wrong information. We absolutely could, and I see it a lot. But that's either because there's an agenda they're trying to push, or they literally should not be the one doing the summarizing and interpreting of information, because they're just ill-equipped, right? So that's that, relative frequency. Another set of relative frequency is in the last column, cumulative percent. It's relative frequency because it's a percent, right? And then it's cumulative because all we're doing is adding. We're adding only the valid percentages, but we're adding nonetheless. So we take 24.5, take it over. When we add 24 plus 8.8, we get 33. When we add 33.3 plus 22.6, we get 56. And when we top it off with our 44, then we get 100. So it's just saying, you know, I'm sure you've heard, and you've done it before, when you say, how many people thought at least that, right? So how many people at least thought it was sometimes wrong? How many people said it's sometimes wrong? Well, if you said it's sometimes wrong, then you probably also said it's You might be in the category of people who said it's always, well, you will be in the category of people who said it's always wrong and almost always wrong. So if you thought it's at least wrong, right? 56% said that. So at least you said that, not even the harsher ones, but at least you said that. That plus all the harsher ones counts, right? And so that's what cumulative is useful for. Or say, you know, how many people practice at least 3 times a day versus, that's a lot. How many people practice at least 3 times a week, or exercise at least 4 times a week, or at least once a week? Yeah, right? So you get the people who said once, the people who said twice, 3, 4, all the way to 7, but who you won't get is the people who said 0, right? If it's 4 times a week, I want to see who practices at least 4 times a week. Well, guess what? You're going to get the people who said at least 4 times, everybody who said 5 times, 6 times, 7 times, right? All of that counts for at least, okay? So that's it. So now a third set of definitions that we got right under our belt, and we will never stumble about this. One thing to note, and one important thing to note, because this is one thing that people stumble over in this slide, is that there's only one variable. There's one variable and one variable only. The variable is what's one's opinion about premarital sex. I don't see any other variable. I don't see any other question about gender or age or anything, right? The only question here is, what is your opinion about premarital sex? And so this frequency table summarizes that for us. That's it. That's it? Good. So let's practice. We've got the same table. What do we call it? A frequency table. We've got the same labels, everything, okay? So question number 1, how many observations are in this frequency table? Hopefully you're saying 1,000. 1,000. What variable is being analyzed here? Hopefully you're saying one's opinions about premarital sex. What are the values here? Hopefully you're saying the valid values only, because that's what's important to the question. If you want to understand whether you're saying the right values, remember what the question is. So if the question is, what's your opinion about premarital sex, then someone not answering the question is not a valid value, right? So the values, 1, 2, 3, 4, as they were coded, or the actual values, always wrong, almost always wrong, wrong sometimes, not wrong at all. Okay, and we have to give it these codes in order for Excel to understand how to run anything, or SPSS, or Stata, or SAS, or anything. Calculators don't do anything with words or letters, right? So we have to give it a number. And if we know if this is a ordered variable, interval, or or ordinal, then we know that the order that we're giving it has to be a specific way. But if this was gender, or if this was religion, right, there's no real order. So this would not necessarily be something we would do. We would do a frequency table, don't get me wrong, but the order, the coding of it would not be, it wouldn't be coded, because you wouldn't know which one to put as 0, 1, 2, 3, and 4, and so on. We'll talk more about that later. So what is the absolute frequency of premarital sex is sometimes wrong? Well, we remember the absolute frequency means absolutely nothing else attached to it. It's just the count, right? And so the count is for premarital sex is sometimes wrong. 144 people said it. Okay, what about the relative frequency? Now we know that number has to be related to something, relative to something. Okay, and so this one is asking for how it's related compared to total people surveyed. Well, hopefully you're seeing, as we responded earlier in question 1, the total people surveyed is 1,000. And so the relative frequency based on the 1,000 is that first column, percent, total percent, right? Not valid percent. So premarital sex is sometimes wrong. The relative frequency here is 14.4. People said percent of the people who were surveyed said that? What percent of people who provided valid responses said that? Well, 144 divided by 636, because that's the total number of valid responses. 144 divided by 636 should give us 22.6%. So now we know that of the total percent, 14.4% said it, but that number is diluted by the, the 23 people who said I don't know, the 1 person who didn't answer, the 340 people whose answers somehow got messed up in the system. So a total of 364 missing observations. So that number takes that away. The valid percentage takes that away, and it says we're not going to dilute these numbers anymore. The actual percentage of people who believe premarital sex is sometimes wrong, 22.6. All right, and then what percent of respondents believe that premarital sex is at least sometimes wrong? We just did this. Is it at least sometimes wrong? Well, if you think it's wrong sometimes, you probably also think the other wrongs too. So a total of 56%. So we can get that number a number of ways, right? We can use our valid percentages and add them all up. We can go to our absolute frequencies and say 156 plus 56 plus 144, add it all up, and we divide that number by 636. That should still give us 56, right? Either way. All right, so now that we've looked at frequency tables, let's look at frequency charts. Why? Because a picture is worth 1,000 words, literally. And so we saw it in our very first slide or two or something. And so the graph type, so we know how to read tables and charts. And so we're just going to learn some of the different types of variables that are best for which type of chart and so on. Okay. So, so here we've got 3 charts, 3 graphs, right? The x-axis is going this way, right? The y-axis is going this way, up and down, right? And so let's look at what the first table chart is showing us. It's the heading says death rates from cancer. All right. And then we've got the y-axis showing probably the death rates, and then the x-axis showing horizontally the years from 1940 to 2000. Okay, so in that chart, it looks like nothing happened. Actually, over the past 50 years, nothing really happened, Death rates from cancer, it went up, but like not much, right, happened. Then we go to the second one. Wait, it's the same heading. Okay. Yeah, it's got the same everything actually, but they've shrunk. It was more spread out in the first one. Now they shrunk it so that we can actually get some good perspective going on there, right? So we get the good perspective, and now we go, oh, wait a minute. Okay, so we stretched it before, not knowing, or maybe we knew, but maybe we didn't know. Another reason why ignorance is not good when we're presenting data to people that is actual data, but now we're interpreting it differently, wrongly, because we don't know what we're doing. So, but in this class, we are learning the right way to do things, okay? So we shrunk it a little, and now we're seeing something. It's not just slightly flat. It's like actually moving up a bit. So then we go to this third one. Whoop, same data, same chart. And what happened? What changed here? Not only did we shrink it, but we also took everything under 120 out. Because if you notice in both of the first 2 charts, death rates weren't at 100 and nothing even started at that level, right? And so that was only that extra air. It's like a potato chip bag, right? All that extra air, then you get 2 little pieces of potato chips. Like, what did I just pay for? So So we got rid of that air. Now we're like, oh, okay, there's the data, there is the pattern, there's the trend, there's what actually happened over those past 50 years. So what happened? Wow, it's like it didn't just creep up, it shot up, right? So something's going on. So someone maybe in the very first top left that provided that data set maybe wanted to make people believe, hey, listen, there's no need for us to continue to fund, cancer research. There's nothing happening. Deaths aren't increasing. I mean, we are having deaths. It's hundreds of thousands of people dying, right? Because that's in thousands. But like people are making a big deal out of it. It's not an increase or anything, it's slightly increased. But then we go to this bottom chart and we go, whoa, it's not slightly increased, it's like for real legitimately increased. So let us start paying more attention to this, and maybe we need to fund this, and maybe we start regulating this types of foods and this type of this and that, right? Because a lot of times it's what's in your system that's causing your system to have issues. Anyways, so just another example of how data might be manipulated knowingly and completely obliviously, right? So pay attention to what goes where, pay attention to scale, because it gives a totally different impression and it can tell a completely different story. All right, let's take a look at another. That was a line graph. Here we've got a bar graph. Excel does bar or column, right? They're the same thing. One goes vertical, one goes horizontal. So each category or value is represented by a bar. What is this data about? What's this data about? So we can see some of the values for the question, but what was the question? Right? We see that some people said heart disease, some people said cancer, some people said cerebrovascular accidents, chronic respiratory, right? So these are the values. These are the things people checked off. Yes, check, right? But what's the question? So this is important because this is an important slide, because we need to, when we are presenting data, we need to make sure that we are actually presenting information in its completeness. Someone could look at this and say, oh, wow, this is the death rates. Someone could look at this and say, oh, maybe this is the number of people that went to hospitals. They didn't die, they just went to the hospital, right? Who knows what this is about? Well, the researcher knows, but he or she did not provide adequate information in this chart. So keep this in mind next time you're creating a chart, to make sure that you provide sufficient information for the audience who is viewing it, who has nothing to do with your data and doesn't know what your study is about, right? Make sure you provide adequate information, okay? The next one is a histogram. Looks very similar to bar graphs, but they do something a little different, and so just make sure you read the slide, but it's important, it's good for ordinal variables, it's also good for interval variables, whereas this slide was not so much good for intervals, right? So here, what is this one about? So here we didn't have any at the bottom where it says heart disease and so on. There's nothing at the top that's a chart title. There's nothing at the bottom that says what these values mean. For the in the x-axis, right? In the y-axis we see counts, so we know that's counts, but we don't know what the x-axis is. Here we see both, even though again no table title, but we can get away with that this time. I mean, don't get away with it, but you can see that the x-axis is about percent Hispanic, the y-axis is the number of states. We're going to assume the United States, but it would help if there was a chart title, right? But we can see that certain number of people, let's say 26 of those states, had between 0 and 5% Hispanic. So stick with me here. The first column, the first bar, right? We see 0 to 5, and that is percent Hispanic. How many people, how many states were 0 to 5% Hispanic? About 26. So over half of the United States, it has there's each state has less than between 0 and 5% Hispanic. So what does the 5 to 10 mean? Hopefully we're saying, let's say 11, or are you saying 13? So 13, because the height of the bar is 13. So we're gonna say 13 states had between 5% and 9.9% Hispanic residents. So what do we think the one over to the far right is? What state do you think it is? Take your guess. We're gonna say New Mexico. So New Mexico is the state that seems to be farther out than every other state. I mean, maybe Texas and maybe California might be the ones in 25 to 30 and 30 to 35 maybe, but New Mexico has 42, so between 40 and 45, right? Between 40 and 45% Hispanic. It may possibly be an outlier, the one further out and not representative of what the rest of the data is saying. Okay. So here's our stem and leaf plot. The stem and leaf plot is interesting because this is what age-old way of doing bar graphs before Excel did it so nicely for us. And so we can see that this is a numerical thing too, so you can definitely do it with interval variables and categorical variables actually, but we can see that essentially we took that very top one and we flipped it over, and now that's an Excel spreadsheet, Excel chart. But what that means, let's go to the very bottom of that first chart. You see 2, and so the first value for 2 is 20, and then a 21, then another 21, and then a 23, and then another 23, and then a 24. So let's go to the top of it. We have a -1. So what's that -1 about? It's -19, -18, -15, right? So one person said that said -19, one person said -18, one person said -15. We can see how many people said 21? 2, right? How many people said 0? Just plain old 0, right? Let's see. 1, 2, 3, 4, 5. 5 people said 0. How many people said wow, 5? Well, gosh, that's a lot. A lot of people said 5 because you go to 0 and you can see 5, 5, 5, 5, 5. A lot of people said 5, right? Okay. And so the same thing we could do with the bottom one, but essentially that's how these bar graphs came to be before technology. All right. We're rounding up now. So frequency charts. Again, let's go back to this line graph. We can see that we can compare groups easily with frequency charts, okay? So we could look at that question we've been asking before, what's your opinion about premarital sex? And now we wanted to see what white people thought and what Black people thought. So for a second, let's take a look at this and see, what did white people think and what did Black people think? Well, it looks like the red line is white and the green line is Black. Can we agree there? Okay. We see how many variables here. Hopefully your answer is 2. Because we have a variable called opinion about sex before marriage, and we've got a variable called race of the respondent. 2 variables. How many values are in the variable race? Well, Your question has two answers, and the answer is white or black. What about sex before marriage, that variable? How many values? That value, always wrong, almost always wrong, wrong sometimes, not wrong at all. So we got 4 values for that, 4 valid values for that, right? Now let's get down to the actual question. What is this table? What is this chart telling us? Well, let's take a look. This chart is saying that white people maybe think that premarital sex is wrong more so than black people, and that it's also not wrong more so than black people. Or this is another example of how data, if in the wrong hands, could totally be misinterpreted, because that's not what this is saying. Now, this lecture, we learned about absolute frequencies and relative frequencies. So what we're looking at here, hopefully you can see there it says count in the y-axis. What we're looking at here are absolute frequencies. So 100 white people, little over 100, said always wrong, right? About 200 or so, 250 white people said not wrong at all. Based on that alone, and then we go to black, black might not even reach the number 100. So what does that tell you? That this data is not, we can't make that interpretation of, well, white people think this more than black people. No, we can't. All that this is saying, and if ever you see something like this, please know, just because of this one lecture, that all that this is saying is that more white people were in this sample than black people. That's it. That's all that we can say here, right? Because if we took these two graphs and separated them and then did what we did with that other line graph and scaled it correctly, you can probably see here that the black is just expanded because of the number of white people that's overpopulating it, right? So if we took the blacks and put them in another table all by itself and rescaled properly, right? Because right now the green, you can see the green, and what in that paper, in that potato chip bag, do we see? A whole lot of air at the top. A whole lot of air at the top. So black shouldn't have had a scale beyond, say, 50, because the number wouldn't get up beyond 50. Whereas the scale is perfect for white because, it goes down to, it goes to 100, goes down, then comes back up. Perfect scale for the dotted red line. Horrible scale with a whole lot of air for green solid line, right? So this is another way of not providing adequate information and therefore interpreting that poorly, okay? So we can't say anything about this. If we made them relative frequency, then we can put them in the same chart, totally. Put them in the same chart, and the relative frequency would be what percentage of white people said, and then what percentage of black people said. So even if there are only 50 black people, we're making it relative to the 50 and not relative to the whole 5,000 people when only 50 of them is black, right? So we're getting rid of all of that air in that potato chip bag. Okay, so pie chart. The only thing I want to point out here, because we've talked about a lot of other issues, but the one thing I want to point out with pie charts is that we have to know the total. We cannot create a pie chart if we don't know the total. And I see this too much for me to not point it out. We have to know the total in order to create a pie chart. You can't say, well, I only know 97% of the data. Well, hopefully in your pie chart, you've got a 3% there that says, don't know. But we're not going to make the whole chart of everything that we do know as 100%, because it's just not the case, right? So the one thing I want to point out is pie charts are awesome, but we have to have understanding of what the entire pie is. And two, as you can see, pie charts have lots of colors and lots of numbers in there. If we don't provide a legend, God knows, only God knows what you're trying to portray in the left, right? Without the legend that's there on the right. Awesome. So here's a summary of how we might, what I would say best use of the different types of charts are. And that's it. Lecture 1 done. Whew. Do some practice.